Hello and welcome to my vvvv Gamma graphics tutorial. So in today's tutorial we're gonna learn how to make a graphic like this. So we're basically using a particle system. So the fuse particle system, which is super great. It's quite easy actually once you start to understand what's happening, and there's a lot of controls that you can apply, and it's really flexible. And also, so as you can see, the particles scale are changing based on the camera position. So at the end of this tutorial, we're also going to learn how to apply this kind of parameters so that it's not only static, but there's a lot of things that you can do. Yeah, so this is a collection of particles. So we're also learning how to distort kind of like a sphere as we did on the previous tutorials, but this one is a particle based one. Okay, so let's get started. So I'm going to start everything from scratch. First of all, let's open up Stride. We need Stride for the rendering, and then we're also going to be using particle system in Fuse. So let's open up those, and then we'll get a scene window first, and then we'll get a root scene, and then we'll get a skybox light. We're not using the lighting today, but just to visualize something on the background. So skybox light is there. And then for rendering today, we're going to be using a node called buffer to render entity, and this is a node to connect a sprite onto it. So we just want to have like a single dot, well, not a single dot, well, group of dots rendered here. And we're going to feed, so this buffer to render entity has a resource input on the left top here. So we're going to be connecting the particle system here so that it draws all the particles with as sprite. And in the sprite there's 6 different input. Well, this one is draw dots, so it doesn't really matter, but it has normal and size and position and color, and also skip as an input. Skip means if something is above this, then you don't draw. You can specify quite a lot of parameters in these particles. So if you want to kill some particles, then just skip. Connecting like skip things here will work. Color, position, and size. We can control everything on the particle system as well, but we can also specify like an additional parameters when you're connecting to sprite. Let's see that later on. So first of all, let's specify what kind of particle system we want to create. Structured. So first we need this node called structured buffer resource, and there is an element count input. And then on the left bottom, it says name, size, and attribute. This is quite handy to keep it out here because it shows when you have an update. For example, if I change the element count, and element count is the amount of particles we want to draw. So let's say we want 2000 particles here, then immediately gets updated here. So it's pretty handy to see what kind of parameters. And later on, if you add position and size, it will all be updated here. So it's quite handy to keep this guy out. And we'll connect this one to this buffer to render entity to make sure that our particle system, which we're going to be building here, will be fed all the way to the buffer to render entity to draw the sprite. So next up, we're going to be using this compute system, and this is like a core node that all the particle system will be fed here, and this will be connected for some. I don't know how to say that, but yeah, the structure is just like this. And then there will be we'll be using a node called compute stage. And there's 3 different nodes. So today we want to do some sort of like a point cloud visualization kind of thing. We don't need the particles to move around, so we only need this. We're going to be using this compute stage, which doesn't have, for example, like a lifetime on the particle, so it's just static, which is handy to when you're drawing something like a point cloud stuff. But there's also an emission stage. There's 3 different stages. There's emission stage, and then there's simulation stage, and there might be more, but I've only used these 3. So this emission stage is with lifetime. So if you want to move around the particles and let it delay it in some point, like 3 seconds, and it delays and things like that, use this emission stage. And then there's also simulation stage. This is more about adding effects like noise, curl noise, and that kind of simulation or effect will be added on this simulation stage. So today we're not going to be using these 2, so we'll only use this one. You'll connect the compute stage to the compute system. So this is the core. And then we also need to connect the structure buffer resource somewhere, and that's going to be connected to compute stage. But right now we don't have an input, and this guy's blue, so it's acting a bit weird. But we'll solve that later on. First of all, let's figure out how to connect structure buffer resource to compute stage. Just right click, configure, and there's show resource input here. So once we bang this, there will be a resource input on the left top of this compute stage. So we just connect this structure buffer resource here, and then it should kind of work. Let's see. So first of all, let's add a color, like a random color is okay. Let's just try figuring out how to build the particle system. So we'll add a set node. There's a node called set. This is very handy. So and we'll verify what kind of parameter we want to have. So we'll add a node called color particle. So we want to set a color. So connect this color particle to the left top of the set, and then we'll connect this set, because this is a GPU void, we can connect it here. And then this guy will become vector 4, because color is based on vector 4. So let's just say RGB. So we want a blue one, maybe a red one. And then as you can see right now, we're not seeing anything, and this guy is giving a little bit of error. It's blue. So what we have to do is press F9 to reset. Now we've lost that white blue node. So yeah, in this particle system, sometimes you need to reset using F9, and this is probably because like it's having some problem inside, and sometimes the particle system doesn't get updated. Like for example, if you change the position and then but the position is not applied, if you're facing that kind of problem, just press F9 to reset the entire vvv, then everything should just work fine. So just keep that in mind. So now we've assigned a color with red, and we've got a black dot here, and this is not what we want. And the reason is because, so right now, so as we've assigned a color here, as you can see from the structure buffer resource, now we have this P color float for, I think it's particle color float for a week. So we can see the structure buffer is for sure feeding this color, but we're not seeing the red dot here. And this is because we also need to feed this color particle right here on the sprite. So, but it's not changing. And I've also faced this problem, and this is probably because I haven't assigned the name for this particle system. I didn't know we had to, but let's just say particle. And then nothing gets updated, but if once you press F9, yes, now we get this red dot on as one sprite, and there's only one because we haven't set the position. And this bug on, if you don't assign a name on structure buffer resource, then nothing gets drawn. I haven't really faced this problem, so maybe it's just because of the version problem, I don't know. But you need, if you don't see things being updated, just make sure to add a name on the structure buffer resource, and then everything should be fine. Yeah, now we've got a name here, size, attribute, P, color, float forward. So yeah, this is like the basics. So now let's keep adding position and other stuff as well. So we want to set another one with position particle, but the problem is we only can connect one compute stage here. If you press plus control plus, yeah, nothing gets added. So we need to add a node called compute group, and this one is a GPU void, so group and GPU void. So this, yeah, now we can connect the position and the color. And here I want to add a position, and there is a node called sphere random, which feeds us like a random position based on sphere. So we'll just add this guy, and now we got P position float 3 updated on the structure buffer resource. But right now we're not seeing anything, and that's because the base default value of the sphere random is 0. So I'll just add 1. Still not seeing anything, and this is probably because it didn't get updated. Press F9. Oop. Oh yeah, there's another problem, sorry. So I haven't add position on sprite right now. It's 0, 0, 0. So I'll add a position particle to the sprite, and here we go. So now we've got 2000 sphere randomed particles drawn all with red. So it's, as you see, it's all what we just wrote. So nothing complicated. I really like this structure. It feels more understandable for me, at least. So yeah, let's just reorganize this. Yep, the source. So right now the particles are there should be 2000, but the problem is it's moving around too much. A sphere random in default, it just keeps feeding random sphere values. So, and there's an input called constant. Once you click this, it just stops. It makes it constant. So yeah, this is pretty good. It also has an input called volume. So if you click this, it makes it a volume, not just a surface, but inner fill will also be added. If we increase the element count, for example, to 10,000, then we see 10,000 particles, but it's pretty hard to count. Yeah. And we don't need the skybox light anymore because this sprite doesn't require any lighting and things like that. It's just a dot. So yeah. Yeah, so this sphere random is quite handy. I really like this node here. There's also a different type of random, I think. If you go fuse random, there's disk random, there's triangle random. So yeah, try out different nodes to see what's interesting for you. So let's try doing something else. So for example, if you want to add, so if we go to fuse, I don't know where it was. So if you look for particles, there's different, you can see a lot of parameters. Like the attribute is this color, and the position is inside this fuse particles and attribute. And here you can find a lot of different parameters that you can specify, like target, strip, size. There are two different types of size: size 2, size, and size 3. Position, particle ID, parent, mass, lifetime, last position. I've never used that one. Cycle, color, axis, apply velocity and age, and things like that. So there's a lot of parameters that you can read and write. So it's really fun. For example, one thing we can do is let's change the color. Oh, it's okay. Yeah, let's just object space and the xy plus z, because it's vector 4, and I just color the particles based on the object space. Does it work? No, it doesn't. I'll just get the position then. Yeah. So now the particles are colored based on the position, which is pretty nice. So as you can see, so the structure is very simple. We just need to make sure that you follow all these steps, and you'll be able to draw a particle that you want. Yeah, so if you set, for example, if you copy this one here and then group with +1, you will be able to add another input, and here we can also set the size. So right now the size, it's set here, but we can also set the size here, size particle, sorry, and then we'll say 0.01, or it could be actually smaller. Configure precision 3, step size 001, and now we can control this parameter a bit more detailed, and then I'll set the size here, and we'll also feed this size on the sprite. Yep. So now we can control the particle size here. Yeah, so this is basically how you add parameters on particles without moving. So now pp position, p color, p position, and the size is specified on this structure buffer resource. Okay, a few more steps. So this is the basic setup for the compute stage. So if you want to add different, for example, if you want to add some noise here, we can add some noise with scalar, and we'll give position as domain. And we'll add, for example, like a multiply scalar because I want to add a float 32. So this is float, but I want to add a sphere random is a vector 3. So we'll connect this one here. And yeah, it's juggy. I don't like this. Let's just connect this one here. Yeah, this is better. So sphere random we added because the position is here. It's specified by this guy, so we didn't need to use that position node. So I just feeded this one here, and then I'll add a +1. Because the noise goes from -1 to +1, -1 to +1. So sphere random is a sphere, but and also want to keep it surfaced. So it's a sphere, but if you apply noise with -1 and +1, it just goes inside and outside. But I don't want that, and so yeah, I just made sure that it's +1. Yeah. So if we add a frequency then the amplitude, yep, now when the amplitude is 0, we're not multiplying anything, so it's okay. But if we add the value, it gets, yeah, it deforms based on the shape, and this is something that we've been doing with the previous tutorials. So yeah, this is pretty cool. We can add some more particles if your machine allows. I mean, this fused particle system is pretty light, so at least on my machine, I haven't really had a problem, so I can keep adding stuff here. Yeah, or can we make it bigger? Yeah, make sure not to make too big, but yeah, we can add different parameters on it. Another thing I wanted to show is, so we can adjust the size here, but I'd rather keep it simple, so I want the base particle size to be 0.008. And here we can also add, for example, like a multiply node here. I'll use this node called multiply scalar, and we'll put it here because size, well, it's a float 32, so it doesn't have to be scalar actually. You can just use the mass. Yeah, I'll just use the math one. And then here, I'll multiply 1 here. So this is the default parameter that we're feeding from all the way from here. It's wireless, and we're getting this 0.08 for all the particles getting out from here. What I want to do next is, for example, there is a node called distance, distance math, and I want to add orbit camera. So what I want to do is I want the particles to change its size based on the camera position. So right now the camera position can be seen here. If I move the camera, the orbit camera will show the position of itself. So if we go to the center, it gets more 0, 0, 0. And I want to shift, left click, and get this position pad out so that we can read this position above. So we'll add a position. So camera position is here, and we want to calculate the distance between camera position. I'll add a camera position, and I'll change this one to camera position. And I want to calculate the position between the particle position and the camera position. So with these two connected to the size and multiply, what happens is that when we get close, as you can see, the particles get smaller. So it's calculating the distance between the camera and the position and the particle position. And this is what's cool about this, is calculating between individual particle position. So as you can see, this part of the particles are getting small, but still the ones at the back is big. So by using this kind of function, you can do quite a lot, like calculating the distance between something and change the color based on that. If the distance is nearby, too close, then just kill that particles. Like there's a lot of controls that you can add on this particle system. So yeah, I really enjoy playing around with the fused particles. And today we only used the compute stage, but if you have time, try playing around with the emission stage and the simulation stage, because those work different. And you can also read like certain position from this compute stage and then apply that to emission stage with the delating function. So the main particles are not delating, it's just moving around, but the particles that's following them are being deleted. And there's a lot of really nice sample patch in the Fuse learn help patch as well. So if you want to get deeper, you want to know deeper on particles, I really suggest checking other help patches as well. So yeah, that was it for today. Thanks for watching, and I'll see you next time.